welcome back, everyone. And I'm going to be announcing the next session, which is going to be just as fascinating, I would imagine. So the ADR, AI data robotics facing environmental issues. So in particular, as I mentioned at the beginning, it's paradox that relates to the risk of increasing energy consumption due to the development of AI data robotics versus our ambition and the need to reduce CO2 emissions and increase sustainability. So I'm going to be handing straight over to Ana Garcia, who I think is with us already.
Yeah, here I am.
Hello, Ana.
Hello,
nice
can you hear me well, Philip?
I can hear you great.
Great being here.
Thank you very much for joining us. I'm going to hand straight over to you so you can introduce the panel and get the session moving. Thank you very much.
Very good. Thank you very much, Philip, and also thank you, of course, to Adra-e project, all the organizers. It's a pleasure being here. This is indeed a very important session for all of us. So we talk about here AI data and robotics and the environment, right? And we know how important these technologies are as digital catalysts to really helping the digital transformation and in particular making industries more efficient. But at the same time, and we can read in the press every day that these technologies are also very, very thirsty, very, very hungry technologies of resources. And of course, we look at energy and therefore to CO consumption, but also there are many other things like using of materials, waste, and the whole life cycle of technology is becoming shorter. So we have fantastic experts today to have good discussion on how to really balance what is this trade-off between the benefits that these technologies bring to really achieve our objectives in Green Deal, etc., with these challenges that we have in relation to the energy consumption and other environmental issues. We will start first with the keynote, and then we will have a fantastic panel with a variety of experts representing different communities and industries. And I would like to call on stage first to our keynote speaker for this session, that is Monique Callisti. And Monique is CEO of Mattel Innovate and also president of Digital for Planet. And well, I think at least myself, I have had the pleasure to really collaborate with Monique for a long time. Also from BDBA, from the Big Data Value Association, we have a collaboration with Digital for Planet, as this topic is indeed very, very relevant for our communities. So Monique, I think you are with us, and I will give you. Yes. I would like to give you the floor for this keynote, previous to our panel discussion.
Can you hear me, Anna?
We can hear you. We cannot see you though.
My video is stopped. I cannot switch it on. So the host has blocked my video. So maybe if someone can.
Oh, we'll get you.
Okay, so that's a good.
Okay,
excellent. That's okay. Good. It's good to see you, Monique.
Good morning, everyone.
Good morning.
Thank you for the invitation, and I'm very glad to be here. So I will try to share with you a few of the learnings, a few of the understandings that we have developed about digital sustainability. It's a very dense argument, so I will try to nail down the point. And I will share with you my slides. I hope you can see them. I'll wait a second for...
perfect, Monique. It's okay, perfect now.
Great. So actually, today I'm talking thanks to two main organizations that powered my work in the last few years. Mattel Innovate is the company that I'm the CEO of, and we created a few years ago a non-for-profit association called Digital for Planet. And this association works very much on promoting the research and development activity in the area of green ICT, green AI data robotics technologies for helping with sustainability of the planet. What do we need to do to chart a course that is green for the future of our planet? First thing is that, sorry, there was a chat. So the first point of reflection is about what are the current main environmental challenges that humanity is called to face. We are all aware of them, but I would like to reiterate a few points. First of all, pollution, air, water, soil contamination. We are assisting to a biodiversity loss that is absolutely dangerous for our ecosystems, for species extinction, but also for human life. And there is an overconsumption of natural resources. We have a very consumeristic approach to life, and this is damaging majorly the environment. We are assisting, we are victims more and more of major extreme weather events caused by climate change. And as you all know, the electronic waste volume is growing at a very fast rate. So it's clear that all this is not only affecting the environment, it's affecting society, it's affecting economies. And as previous speakers earlier in the morning have said, we must act now. The call from the planet is very clear. Of course, technologists, researchers are at work at several levels, as we have already heard also from the previous panel. And ICT is promising a lot. And the promise is that, of course, we can use more efficiently resources, we can optimize processes and supply chains. We can also use ICT to monitor the environment, predict and prevent disasters, analyzing data and forecasting events. We can optimize also resource management and allocation so that we save on energy consumptions, but also on resource consumption. And clearly, especially AI and data combined can help with decision-making support for humans in many critical situations. Now, this is there's several reports available here. I mentioned a few, and I guess when the slides will be made available, you can dig a little bit better. But basically, there are several recent reports that say how much the use of ICT across vertical sectors could help in terms of saving energy, reducing CO2 footprint, and helping address climate change situation. But clearly, and we all know that there is a rebound effect. There is so ICT and other technologies in particular are a big part of the problem. They are not only part of the solution, but they consume energy. They have an important carbon footprint. They are damaging the environment, both at infrastructure level and also at devices level. We have to build devices that people change more and more frequently. And in general, technology is also inducing overconsumption. We have a culture of consumerism and disposability. We rather throw away things and upgrade to the new phone every too often, if you ask me. I have 3 daughters. And all this, it's creating clearly a situation in which we have to go back to the way in which we thought technologies can help addressing sustainability challenges. Now, let me say that this is not urgent. It's more than urgent. Our planet is calling. We have evidence all across the world that there are many aspects that are becoming very dangerous for humanity, for many species. And we really need to make sure that research, industry, policymaker, government, citizens are all aligned in addressing this call. Today here, of course, what we try to do is to focus more on what as technologists or as researcher we can do to chart this course for green digitalization. It's clear that we cannot, that our future is related and is very much dependent on digitalization. On the other hand, we must reach a trade-off that allows us to balance out things across economic, societal, and environmental aspects. So what do we need to get there? As I said, we need several ingredients. We need technology, we need sustainability by design, we need policies that allow to enforce, check, controls, and regulations that allow also to identify liability and follow up on enforcing rules at individual and organizational level. Indeed, we need to educate, we must educate young, but even, and most of all, older people, also in the way we manage our lives, but also our companies, our businesses. And with respect to that, there is a lot of work that we need to do also to ensure that the approach to a green digitalization is a holistic approach, which involves multi-stakeholders and multi-stakeholder driven and multidisciplinary by design. Now, clearly, sorry, they are, okay. So the green power, today we're focusing more on AI, data, and robotics. So let's try to zoom into this aspect, and let's try to have a look at the two sides of the coin, the positive and the negative. So as we have heard also from previous intervention, we have across artificial intelligence, big data, and robotics, evidence that these technologies are changing the way in which we can work, the way in which we can anticipate situation, not only recover from situation. And clearly we have a lot of instruments, thanks also to not only to algorithms that many times are algorithms that existed already, that were depicted for many years, but the fact that we have a computing power and a storage capacity that we have never seen before allows to use AI and big data in combination in a way that we can really make sure that we identify trends, we change decisions on the fly, we try to monitor at real time what is the impact of specific choices across many domains, from healthcare to environmental monitoring, traffic control in cities, and so on and so forth. And of course, robots are the old robotics research and innovation are making a huge difference across several domains. It's enough to think about, for instance, precision agriculture, or the use of autonomous and intelligence robots underwater for inspecting pipelines, and you name it. So the number of applications that already use other technologies and that are helping to address environmental challenges is huge. There is a rich literature about this. But clearly, the more we zoom into specific applications, the more we understand and we can quantify what this means. For instance, across transport, construction, and manufacturing, there are several main challenges. One of the aspects is efficiency and optimization. This can lead to waste of money, resources, but also time. And this can lead to traffic congestions, construction delays, or delays also in the production pipelines. Safety, whenever you use machinery, it's a major concern. And not only robots can help with safety, but they must be designed so that they are themselves safer and help addressing situations in which we have high economic and human costs, like accidents. But also the reduction of greenhouse gas emissions, the reduction of waste is key in all these verticals, as well as the fact that there is a shortage of labor across these sectors that can be somehow helped with the use of robotics, with the use of skilled, of course, also digitally skilled labor. Now, it all sounds very promising. As I said, we have several research and innovation initiatives that are very much looking at, real-time data analysis for supporting decision making or for automating many of the aspects, for instance, in network management, in specific construction sites. We can identify bottlenecks, and we can also prevent repetitive tasks to be done by machines in a more efficient way. But of course, there's a lot of work that needs to be done at research and development level in terms of advancing the algorithmic part, especially when we come to optimization of very complex multi-process settings. And also when we need real-time optimization, think only about also traffic control and automated driving. This cannot exist if we're not sure that we have a resilient network, but also optimized processes that allow to control several aspects that lead to a safe situation. In particular, we are seeing an increasing number of sensors, of machines that can help also in terms of safety. And of course, what we have to make sure is that also, for instance, with, I don't know, air pollution detection or fire detection, clearly we need to optimize all processes from data aggregation to data processing and eventually data transmission when the reasoning is not local and is not at the edge where the situation occurs. Now, another point is that AI and big data, as we mentioned, are also a big part of the solution when it comes to being able to optimize consumption of energy or resource shortage. And there are some figures and some recent reports that say that Adra solution could have the potential to cut global greenhouse gas emissions in other sectors by 15% by 2030. And for instance, AI alone could be shaved off 5 to 10% of global greenhouse gas emissions. But clearly there is a lot of research that is needed also to understand what can be the impact of AI, data, and robotics also in the overall life cycles of products, devices, and infrastructure that we're using for our everyday life, but also for protecting the environment. Clearly, another aspect is that in many domains we have a shortage of skills. We have a shortage of digitally skilled people, or simply people that are able to follow up on the fast pace of technology transformation. In this respect, of course, collaborative robots or other machines that are supported by strong AI algorithms can help a lot, speeding up, but also taking the right decisions. Clearly here, and I like very much a point that was made in the first keynote about, the empathy and the common sense of robots. This applies also in a way to any AI machine that we rely upon when we want to take decisions. So, and this human-machine, human-robots, human-AI interaction is still a field where we need a lot more of investigation. Now, what does it take to get there? So let's try to have a constructive approach. So we know Adra can help. How this can happen, how these technologies can help transforming many of the applications, many of the solutions and systems that are deployed. Well, I think that in Europe, especially in Europe, we value core fundamental digital rights to be respected and to be put at the center of our digital transformation. The digital transformation of our society, of our economy, must go hand in hand with respect of the core fundamental rights of humans. And therefore, Adra technologies must be designed with this in mind. We have to enforce transparency at all levels to make sure that it's possible to control how these technologies are designed, are developed, but also used. We have to consider that there are vulnerabilities that we're not even aware of in scenarios where we discover with the machines what kind of threats can raise up. And this leads to severe and serious ethical consideration, but also liability consideration. Who is responsible for what when something goes wrong and there is a mix of humans and machine involved in the accident, right? These are core aspects that several researchers, by the way, not only policymakers and public authorities are discussing and have put on the table of discussion. Where in Europe we have several Data Act, AI Act, and you name it. There's a lot of work at policy level that is helping in this direction. But we also have to make sure that we work with regulators to allow these technologies to be able to speak to each other, to avoid silos situations in which citizens have no choice over which they can use and how they can use. That's why standards and interoperability should be very much at the core of our research agendas. But first of all, we also need to step back for a second and say, okay, but how do we decarbonize AI, data, and robotics? This is not an easy challenge. If we want other technologies, AI, data, and robotics to help us at societal, economic, and environmental level, they must turn green. So we have to rethink the way these technologies are developed and designed. Now, about the cost, we mentioned them in the opening of my speech, but here I added a few slides. We can go through them pretty quickly. That point out some specific, weaknesses in terms of environmental cost of Adra technologies. So training complex models, but also inference, given that it's Gen AI, for instance, is more and more used, requires a huge amount of electricity. And this electricity, most of the times, is produced by fossil fuels and not by clean energy. Data centers are increasing their electricity and thereby CO2 footprint when electricity that is deployed is not green and renewable at an incredibly scary pace. We have statistics that say if data centers were a country, they would rank as the 5th largest energy consumer country as of today. And for what concerns robots, we need to make sure that the power that they are powered by greener energy, but also that they are built by minimizing the impact on the planet when we extract materials, and that possibly we use recycled material or material that are more eco-friendly when we build them. We mentioned already the e-waste, so I won't spend more time on this, but what I wanted also to make you think or think together with you about is the fact that so energy is one aspect, CO2 footprint is another aspect, but also there is a material impact. The material impact comes from the fact that we use more and more devices. We do not repair them. As soon as there is the new phone, the new gadget available, we have the tendency to buy and to consume. And this consumption has a huge effect on our planets. And not only at planet level, but also at health of the inhabitants of the planet. And we have microplastic polluting water, air is polluted, and this is increasing with this damage of the environment that we are not being able to control in a proper way. So data is very clear. We are not getting better. We are getting worse despite all our efforts. So we need to change things, because you have to consider what does it mean in terms of diverse negative effects. So it's not like, you know, you use your phone here and that's the local area in which maybe the radiation have a negative effect. No, to build that phone, you have to consume energy, you have to consume water, you have to extract minerals, and the overall ecosystem, several ecosystems are being damaged. In the oceans, in the forest, in many areas of our planet, we are assisting at this disturbance that technology has brought in. And how can we reverse to bring back this ecosystem in a balanced situation? Well, it's a big challenge. We're all here discussing about that. No one of us has the final answer, but we all want to change something, and we want to try to identify the ways ahead. So now, working across several also Horizon projects with Digital for Planet and Martel, we are working on several aspects. And here I did a little bit of a catalog of the main pressing points in the agenda for future Adra developments, to be taken, of course, cum grano salis, in the sense that, you know, we have more or less advanced work in several of these domains. And sometimes it's a little bit artificial to say sustainable AI and big data versus robotics, because robotics is powered by AI and data. So in a way, this distinction is more like to say, okay, we can do in this area more in that respect than in others. So a first point that I would like you to consider is the fact that more and more we are living in a so-called computing continuum. What does this mean? That we cannot isolate the impact of one or the other technology without considering the overall effects. The fact that these technologies to work, they are integrated with each other. So their consumption in terms of energy, their carbon footprint is very much interrelated. So if we want to do better, we have to act across several directions. And that's why I said that, for instance, we need more efficient algorithm in terms of energy consumption. We need responsible and optimized data collection. How much data we collect and we store that we don't need. This is consuming energy. Clean your inbox, delete files that are avoid duplication of data. I mean, these are simple things, but we organized in the past with some banks, some you know, awareness, small operations that you can do, that we can all do. And imagine if this was done at global level across all organizations and individuals. Then think of powering, we need to power data centers with greener technology, but also not only the data centers, also the edge nodes and devices, because it's more and more the case that with intelligence moving at the edge, there is a big consumption of energy and a major carbon footprint also at the edge. And for data and edges to be greener, of course, we have to think what connects them. Networks, 6G non-terrestrial networks must play a major role also in ensuring a greener connectivity that is not only super powerful, resilient, but it's also allowing to minimize the CO2 footprint. Now, the life cycle assessment, you know, from what it takes from extraction of minerals to deployment and disposability of them, it's still a major aspect. When it comes to robots, here I put a few items, but with the first keynote, we have heard several very important points of reflection that is not only about, you know, how the material part of the robots, you know, it's not just about building robots that are biodegradable, that they reused energy efficiently, and so on and so forth. But it's about also giving them, empowering them with so-called common sense, up to which extent, of course, I leave it to the specialists here. But this common sense that is so difficult even for some humans to apply should be something that guides behavior, especially in unexpected and unpredictable conditions. Now, trying to speed up, because I would like to get to the third part that is maybe the most dense. But again, there are ethical and let's say policy, societal remarks that are at the core of everything we said. For me, what is very important is that we realize that when we put our head as scientists and technologists, we cannot forget about the fact that there can be biases, that we must explain why technology works in a certain way. We must provide transparent algorithms so that we can also get back to what went wrong if something gets wrong. We must design technologies with responsibility, with a strong sense of responsibility that what we do as technologies has an impact on the human life, on the society, on the economy, and that we need to trace back what has happened to improve, to prevent, and to forecast. Also, an important point that I would like to mention is that it's not only about being more efficient in digital terms, it's also about being more sufficient. So I think that we should shift from digital efficiency to digital sufficiency, which is a very important concept. I will get back to towards the end of my talk to this, which means we should not use digital when it's not needed. We should avoid to consume digital when we can do differently. So now, even though we have highlighted in the previous two slides, what we should do, so the main research agenda points about transitioning Adra to greener Adra, I would argue this is still not enough. So what we argue at Digital for Planet and Martel is that we need a more radical and holistic approach. What does that mean? We first of all need to make sure that circular economy happens in a way that the overall economy transitions towards net zero. And what do we need to get there? First of all, we need good measurement approaches to understand what is the net impact of ICT. We know we will not live with ICT, okay, fair enough. But how to measure that in two situations, one with, one without ICT, at the end of the day, we achieve the same result in terms of environmental footprint. Also, we need to work, we need to bring different stakeholders together, because it has not become, it's not possible to solve problems in an isolated way. We have to have case studies that allow also across different sectors in which different stakeholders come together, analyze, test, trial, and build up on a, let's say, step-by-step approach. And also what we need to do for all the users of the technologies, we need to provide guidelines. We need to give them the means so that they understand in which way technologies can be used to go towards a net zero situation. So I mentioned before digital sufficiency, but another point that I would like to make is about dematerializations of our society. So providing products and services is promising, and this has been, promoted by many people by now, by many researchers, by many experts. But of course, this only works if you assume that there is a circularity of the economy. Otherwise, if for providing the services, at the end of the day, there is no net zero footprint, of course, even the dematerialization is not leading to the desired effect. Now, when we look at further investigation and work, and here I wanted to share with you a few thoughts that can help maybe looking forward and identify where Europe should lead or should push for further investment at R&D level. I think, as I said, we need credible end-to-end quantitative assessments of net environmental impact with and without specific solutions. Now, there have been, the European Green Digital Coalition that Europe has been launching a couple of years ago have delivered in April their methodologies, the decarbonization methodology that helps across several scenarios and different types of organization to assess and quantify their carbon footprint impact. But here there are some reflections that I would like to do with you. First of all, we need to have the appropriate metrics. So I've seen, or for sure you have read many, announcements from big companies, especially about decarbonization, what they have achieved. But what they have achieved, sometimes it's good if you look at a specific metric, but the net effect is not necessarily much better. So, for instance, if you look at carbon intensity versus total carbon emission, here the size matters. So if the absolute CO2 emission is not reduced, as well as the non-renewable resource consumption, then the net effect is not zero and is not positive. Also, to say that we compensate a long time, it's a little bit misleading. It's not because we put data centers in places where it's very cold that at the end of the day we have less impact on the environment. No, because overall during the year, depending on how cold winters are, it's true that the impact can be mitigated, but the overall CO2 footprint remains the same because the production of heat, the production of CO2 emissions stays the same. Also, AI versus gas emission reduction. There is a way out. There is some promising directions because, for instance, sustainability is not only about CO2 reduction. It's also about reduction of material. It's also about reduction of energy consumption. And that's why we have to be very careful when we choose metrics to assess the impact of a given technology, to not use proxy metrics. Like, sometimes we hear, yes, we have optimized things at level of energy consumption. But then if you look at the overall CO2 emission, if you don't use energy that is renewable, then at the end of the day, you didn't do better overall. So this optimization must take into account the interdependability of the different metrics and of the different factors. Also, when we look at, I mentioned before about this continuum, continuum, the computing, the networking, the connected, the digitally connected society and economy we're in. So if we optimize nodes and we do not optimize the infrastructure, the net balance is still not positive. If we optimize only networks and we have very energy consuming devices or very obsolete devices, the net balance will always, again, not be positive. Now, another point is that
Monique, I'm very sorry for interrupting, but we are very much over time, so I really ask you to close as soon as possible, as we have 6 people in the panel now.
Sure. Sorry, I lost track. So I will come to very quickly. It's my last few slides. I just wanted to leave for you these few slides that are more about, what kind of investigation we need to do more. And I would like then to pass to this point, that is the closing. So Sustainability is not enough. At the end of the day, that's the main message that I would like to leave you with, because it's keeping the food steady on the gas pedal when we really need to brake. So now we have to go reverse gear. And that's a point that we have started investigating at Digital for Planet by focusing on the concept of regeneration. So it's not just only that you try to do as good as you can, but you actively improve and restore the environment and ecosystem. So you try to go backward. And by going backward, it's not that you do by going to a situation that the last scientists remember. No, you have to have a continuous process of regeneration. And regeneration can happen at the level of the environment, at the economic, and at the social level. I left you here a few pointers because the key idea is very much to help revitalize, leading to a net positive impact. The idea is here, I wanted to give you some examples so we're not alone. There are other people, many other people, and they are trying to understand via an analysis of the dynamics of human activity, innovation, discovery, how they are combined together so that we can help to regenerate urban spaces, regenerate agriculture, but also understand how across several domains we can influence positive trends that are helping not only to minimize impact, but do better than what it was before. Now, my conclusion, sustainability, we can do better at many levels. Digitalization must become a driver for decarbonization. And to this purpose, we need to change the way ICT and in particular Adra technologies are engineered, are used, are developed. And it's clear that these technologies can play a role across many vertical sectors. We have mentioned 3: construction, traffic, and transport, but across many other domains from agriculture, healthcare, they are helping a lot. However, there is a rebound effect. There is a negative effect, and we have therefore to assure that we have a more radical approach to entire life cycle. And several areas still require more investigation in a multidisciplinary and multi-stakeholder perspective. Very happy that today several people have already mentioned and stressed some of these aspects. So the idea is that for us, AI, big data, and robotics can become the architects of a regenerative future, analyzing vast data sets to optimize resource use, guide restoration efforts, and allow humans and robots to heal our planet. So this is our vision, and we are at work to make it happen. Thank you very much.
Thank you very much. Thank you, Monique, for this great overview. And I would have loved to have a dialogue now with you, but we are 15 minutes over time. So we will leave that to the experts panelists that are already with us. And if you don't mind, stop sharing so I can share and present. That's fantastic. Thank you very much, Monique. And please stay with us as there must be some questions or also you might comment to what is coming now. So now we will go a bit more in depth in different verticals, also in different areas of expertise, and we are going to touch both on the both sides, not that the usage of these technologies really for sustainability and in particular to improve our ecological footprint, so to speak, but also the contrary. And we will discuss these strategies. And Monique has already provided a great overview, but I would like to actually discuss with all the panelists a bit this balance in between these strategies, what we really need to put more attention to. We are going to start, instead of introducing all the speakers at the same time, we are going to have a first round where I'm going to introduce each of the speakers. I'm going to ask them, each of them, to give a bit more information about how they fit into the topic, and already to bring a few examples in one direction or the other, or a bit their perspectives to the topic. And we are going to start with Petri Milimaki from the University of Helsinki, and I know, Petri, you are also a part of the ELIS network, board member of Adra, but I leave to you also to present to everyone your different roles and how this topic really touches your, your heart. Thank you.
Thank you, Anna. Just to make sure we are on the same page, so how long do you want me to use now?
So the first round, we give 5 minutes per person.
5 minutes, yeah. Okay, so thank you, Monique, for an excellent keynote, and I also enjoyed immensely the keynotes earlier today. So I think they were all excellent. So my background is I'm a AI professor, computer scientist by education. So it's like mostly from the technology that I look at this. So I think we all agree that AI is a great technology that we wish to use in all areas of the society, but there are downsides. This energy or a kind of a CO2 or whatever, however it is measured, is one downside. And maybe looking at that point, to me, to understand like what we are talking about, I picked a single number to give us an idea. To train a Llama 2 level model with machine learning produces the same amount of CO2 as an average US citizen produces in 16 years. So just to give a number, I mean, like, and these numbers are increasing. So it's obvious that we cannot afford to continue on this track. So my question has been like, how many foundation models, how many of these big models we need? So to reverse the question, like to look back in history, like I could also ask, like, how many internets did we need? We only built one. How many highways do we need between two cities? We normally have only one. How many operating systems do we need in the world? One for each company? No, there are a couple of commercial ones, and then we focus on using the open source tools that we have. So I would like to have the same mentality in building AI, that let's agree that we can build something together as a kind of a platform or a foundation on top of which each party can then build their own tools. So this would be much more cost effective and also more energy friendly. So as was mentioned already in the morning, most people talk about the learning phase of AI or the machine learning, but like if you implement it as a cloud-based service and you have millions of users per day, then the inference part starts to become a significant factor as well. So let's not forget about that. So what can be done? My brief thoughts. So immediately, I think we should be still continue to invest in this current HPC hardware, because the dominant paradigm is still very much this kind of large-scale AI systems with a lot of data. But let's pool our resources together to build together results that we can share to some extent, not unnecessarily duplicate the efforts, and make sure that the current HPC and data center solutions are as green or sustainable as possible. But then at the same time, I think we should look ahead and prepare for the future. So in the morning, the excellent keynotes talked about this, and also Monique talked about this continuum. So let's take a look at the whole, an engineer would say it like the full stack of AI, going from sensors, robotics, real world, IoT, to data, computing, and AI. So it's not only the cloud or the HPC we are talking about, and many people think that the game is lost because it's ruled by big players like NVIDIA and AMD. But if we take a look at the full stack, then we realize that there are a lot of silicon on the way. There are these personal devices that we are using, phones, pads, watches, so on. And on the way between these devices and the cloud, there may be devices like there's mobile networks, and not many people seem to remember that, for example, Nokia and Ericsson are the big players there, and they produce their own hardware solutions. So Europe has a clear advantage in certain areas. So let's think of the full stack additional positive aspects, if we think of the, I mean, edge computing, maybe it's not a good phrase for this all. I would rather talk about like the thinking of the continuum or the full stack at the same time, but like additional benefits. Privacy was mentioned, that if we don't use cloud but keep our data to ourselves, it's more private, it's more secure. One thing that wasn't mentioned in the morning was this response time. So sometimes, like in simultaneous translation, you want to have a fast response time, or maybe remote surgery, or there are a lot of examples like that. So I think we haven't lost the game, and we have clear advantages in Europe. Let's just focus on the real stuff. So and if we wait for the American big tech to create us the solutions, I don't think this is going to happen, because they are now in a good position. So for them, it's much more beneficial to try to maintain this current brute force large scale AI paradigm as long as possible, because they got there first. But that's not the end of the story. Let's be careful about that. So also other issues like fixing the this paradigm. I think there's a lot of going on in Europe, how to develop AI and machine learning to be more efficient, and also more to have more common sense, as Thibault said in the morning. So I think we can lead this development. Let's not wait for the big tech to do it. They won't do it. And one of my favorite quotes is from Jan LeCun, the CTO of Meta, who said, like, people often wonder, why did we have this AI revolution now? And he says that, he claims that, and I agree fully, that this is because in AI, we researchers, we shared our results and we shared the data sets. And that's why this development was so quick. If now we let the closed companies to lead the development, the development will be much slower. So let's keep things open. Maybe that's my first comments, and
Excellent, Petri. Just in the first round, besides give us a very good set of strategies, not only for this panel, but the previous panel, but just I'm very happy that you brought up this topic of how many models we need. And it's not the first time that I'm with you in a panel and you bring up this important question. And I think for the other topics that you have highlighted, like the HPC systems, we have actually Jean-Philippe, who will tell us more. Also for the efficient AI, we have Enzo and Jean-Willem, who will tell us more. And very good this storyline of the not to duplicate and sharing, and the full stack of AI also to look at. So took note of all these things to take to the final round of discussions. And now I would like to stay of course with us. And before calling Chris, I just want to say to all the audience and all the participants, because many of you are very active in this domain as well. Please keep posting your comments, questions. Also, as we are discussing strategies, give us your viewpoint on these strategies, and of course, questions and answers. I hope we have the time. But I would like to invite now Chris de Kuber from the European Factories of the Future Association. And with Chris also, I have had the opportunity to collaborate quite a lot. I'm very happy that you are here, Chris, also giving us the perspective from the manufacturing industries. And I will leave for you this visual that I think you will use.
Thanks a lot, Anna, for the introduction, and thanks a lot for having me. So yes, when Anna was asking for a visual, that's the one I thought of. Actually, when putting it, or when selecting it, I realized that about 1 year ago, a bit more than 1 year ago, in one other Adra event, a related event, I used this slide. So somehow that shows that perhaps I'm coherent. Perhaps the question arises, what's new about this? So just now one step back, I will come back to that slide. So Adra is the partner with the European Commission for the partnership that's called now Made in Europe. When it started back in 2010, it was the Factories of the Future partnership. So indeed, it's all about manufacturing. And data, for sure, data and robotics were already key to the partnership when it started in 2010. AI came in, and definitely the speed in which AI is being included is increasing there as well. But for sure, the whole matter of using data in factories or in value networks is to have optimized value networks, to have optimized factories. That relates to factory efficiency, it relates to throughput, it relates to quality, it relates to a lot of things. Now, this visual is about a set of projects that started in 2019, 2020, well, from the call, that is specifically about energy efficiency in manufacturing. So, and it's also actually the time towards the end of Horizon 2020 that AI became more, a hot topic within the European scene. And this set of projects actually endeavored what many projects in Factories of the Future and other sectors do when it relates to data. It's first of all, assess the situation in use cases and realize, well, where is the data? How do we get the data? What data do we have? Then make sure to get perhaps more data, data that is qualitative, that you can rely on, and then obtain some insight from that data. And you see here, you don't need to go into details, of course, and I won't, but you see here different levels, and many projects, they address these levels. First, getting data, overcoming interoperability aspects in obtaining them, making sense of them, and then creating insight, monitoring in an insightful way. And in the levels 4 and 5 of this pathway, because that's what it's called, you really are taking informed decisions. And informed decisions, actually, it was one of the bullet points of the keynote we had before. So it's all about that. It's about reliable decisions. And the more advanced you get, the more real time you get. And the more, optimal your processes would run. And in this case, the subject was the energy efficiency of the processes. And AI was already introduced in these projects in a way. I say in a way because for sure also in manufacturing, the point was not straight away to have necessarily big data. It's first to have good data to start with and to then build upon this knowledge that you gather. So in the meantime, many other projects started also made in Europe, and energy efficiency or environmental sustainability has been also very much common to many of the projects. I can come back to that too. There's different ways to address the topic now of foundation models, generative AI, the need for big data. We have heard about frugal approaches, edge approaches. I'm quite sure we'll come back to that in the discussion, and I'll leave it to this now for the introduction round. Thank you.
That's very good. Thank you, Chris. And it's very good to see how many projects now they are focused on this energy efficiency. And actually, yes, we left to the discussion later on. I'm curious to know, the awareness of the manufacturing industries really, and also on the consumption side on the usage of these technologies. But let's move on, and we go back to this discussion in a moment. And now I want to welcome Armando Carrillo. And Armando, I don't know you, so it's great that we met. We are meeting here. And Armando represents the Secretary General actually of the European Rail Research Network. And I give you the floor, and I think you also have this nice visual to introduce your case.
So thank you very much. It's an honor to be here, invited in this very interesting area. I am representing Rail Research University and centers in Europe. We are 36, that's Euronext, and we participate quite often and also coordinate some projects in the European level in the framework of the Europe's Rail, which is the joint undertaking for rail research. And while we are talking about all these areas that deal with how to save and how to grow without producing CO2, well, it's for everyone at least understood that doing it with the railway, it's a good way to do it, and we can actually grow transporting the same amount of persons and freight without producing CO2. Some of them, I usually hear it also at European level that when they electrify all lorries and cars, then this will be solved. But that is not the advantage of railways there. The advantage of railways can be seen here in this visual, which is basically because of the friction and the contact point between the railway steel wheel against the rail, and which is about 3 times or 4 times lower to move the same amount of load on rails than with road mode. This all comes from this historical development. So humans realized that in recurrent transportation lines, it was better to actually build rails and move all the cargo with first with wooden rails that they broke quite easy. So they start to implement new materials, and they come up with the final solution, which has been there for a while already, and it's difficult to find something better. Now there's like magnetic levitation, but it implies a lot of technology, and it's on development, but still there's still against steel, it's at this point unbeatable. And you can see the contact point of the wheel, railway wheel against the rail compared to the standard rubber against the asphalt. It also, for transporting the same amount of cargo, railways occupy less space. You have like the comparison here as an old autobahn compared to the same or even more capacity railway line, which is also in terms of biodiversity, in terms of occupation of the space, it's less. There are some areas in which railways are better, also noise and etc. Of course, I need to talk about the advantages, and I need to talk as well about the challenges. Of course, we have higher the upstream costs and downstream costs of the railways, how to build and how to organize them, how to maintain them, how to increase the quality and the reliability of them, and how to deal with the regulatory and administrative challenges. It's much harder, but it's here where in these soft areas, the AI could help us a lot. How to increase the flexibility of railways. Of course, AI cannot build the railways where they are not, but they can help us to give more flexibility to these fixed schedules, or it can help us to predict better maintenance of the railways and the trains and all that it implies. And it can also help us to deal with the crowds, with the safety, with the delays, with the logistics, how to organize. So it's a question of organizing it better. And then it also has some lot of advantages when dealing with complex regulations between the countries. That's one of the most difficult part that railways face because it has been historically developed in different countries. So we have different regulations, and the interoperability aspects are not yet solved because it's dealing with a lot of burden administrative questions between the countries, between the regulations, so that is all these bureaucratic inefficiencies. It could be solved in a digital manner. So that's a lot of possibilities to improve these, having a more efficient way of dealing with all this data that surrounds railway. And as final of my, and going in line with the previous presenter, so that we don't have to create more systems, or we don't have to reinvent the wheel. I always makes me laugh when, for example, Elon Musk says, "Okay, I'm start digging now in Las Vegas, and I'm going to build tunnels, and then we will put cars that will go automatic then." And then he realized that he can put one car after the other car. And then he will realize that if we put rails there, it will be more efficient to transport there. And then he will finally invent metro. So we are dealing, we are seeing some kind of evolutions that they are not realizing about the advantage of systems that are proven and that will be more efficient, and they do a much more efficient use of the energy than railways, because that is where the advantage relies on this efficiency, on the friction and on the organization. So that would be well, a first point of my intervention today. Thank you very much.
Very good, Armando. It's very nice also to see, you know, when you say, okay, this way of transport, railway, it's by itself already greener than others, no? And now how really AI can help us to make this transport more efficient, more flexible, less delays, so that people utilize that more. And yeah, very interesting case. And we will be back later on to more strategies from your side. Stay here with us, and please, to the audience again, keep posting your comments. Now we are going to move a bit from more sectorial, manufacturing, transport. Both our domains are very, let's say, energy focused, and we look more at the technologies. And following a bit the introduction from or the intervention from Petri about the HPC and also the data centers, I have big pleasure to have with us today Jean-Philippe Nominet from the European Technology Platform for HPC. And let me see whether I can welcome him. And Jean-Philippe, the floor is yours. So you also introduce the case for you in this first round. Thank you very much.
Thank you, Anna. Thank you for the invitation and this opportunity to take part in this interesting discussion. Good morning or good afternoon for some of you in earlier time zone. It might be good morning, but hello everybody. Well, let me take 1 minute to start with that, telling you where I do speak from. As a board member of this association, European Technology Platform for High Performance Computing, since 12 years. To keep it simple, let's say we are an industry-led think tank to promote European R&I in the domain of HPC. And it's at the service of Europe's competitiveness, I would say, from technology to science and society, industry, whatever is important for our independence and competitiveness. And we try to help foster the growth of an ecosystem starting from technology. Our roots are in technology, but we want to take a wider vision. So typically it's a private industry-led, not-for-profit association. But out of our more than 100 members from 20 plus countries, we have, yes, a majority of private companies, large and smaller ones, a lot of SMEs. But we have a significant fraction also of, I would say, public, more research actors, players. It's by I know, 55, 45%, for instance. So we are happy to mix vendors, any kind of technology, component, subsystem provider, but also research labs in the area, users of technology, developers of applications, and so on and so forth. And again, mixing academia and industry, and in our opinion, is very important and extremely fruitful. We tend to take a very wide definition of HPC. You might find this excessive, but for me, I call HPC everything that goes beyond commodity. That is, as soon as you need some computing power or data processing capacity going beyond mere commodity, I would call it HPC. But to avoid confusions and to focus a little bit, I would say today we could take HPC in the sense of larger systems and facilities we put in typically big computing centers and mostly public ones, and we put at the service of any kind of application. That's what would make things clearer. And we know the difference between edge, between HPC, etc. But we like to talk continuum, as was mentioned before in other talks. And we even created and led this continuum initiative with, I would say, most, if not all, the big players, other associations in the area of digital technologies and applications in Europe, from 5G, big data, even math. Okay, and our main activity is to produce research agendas to push that towards the HPC joint undertaking, which is the overarching entity trying to put together HPC equipment co-funded with countries and technology to set up those infrastructures. And we try to influence positively your HPC so that they put in place good technical work programs for M&I projects, but also education and training action and so on and so forth. So that's very quickly, in a nutshell, our association. Now, a few hints. These are maybe on the ideas or topics. I could elaborate a little bit more in the next half an hour, or in the chat, or anytime offline with you. I would be happy to have this continuation of discussion. So let's say if we take those big computing centers, we serve any kind of vertical, any kind of application. And in particular, like was nicely illustrated just before me, those areas that need to be very careful about in environment and energy consumption, but environmental aspects at large. So transportation, rail is an example, aeronautics, another one, can be production of energy, can be transportation of energy, it can come from very basic stuff on combustion to smart power grid management, etc. HPC, virtually, it's an enabler, very generically, for any kind of application. So, and as such, it's extremely interesting, ubiquitous. And in those computing centers we tend to serve an extreme diversity of applications. And that's a difficulty by itself, because we cannot be extremely specialized. We cannot fix boundary conditions once and keep them. No, we have to be flexible, evolutive, and serve many applications with different profiles. So it's extremely difficult, even if we take energy consumption and environment aspect at large very seriously. It's extremely difficult to optimize this whole. So let's say maybe our rebound effects or specific powers effects is we have big megawatts. We want to use them. We don't want to be frugal. We want to be efficient. That is, in this envelope, we want to reduce the average power consumption compared with the peak. And that's possible at many different technical levels. And above all, we want to serve as many applications as possible. That is, if we reduce a job cost in terms of time and energy, you can offer the opportunity for more jobs to run. And if we are good together with the applications, because it's a joint effort, we can do more good science and engineering within a given budget. So the good side is we have bounds. If we have a 10 megawatts computing center, it cannot be more. And what we have to do is to lower the average use altogether for thousands of users and to try to push as many jobs and applications as possible. And this is a joint optimization process between technology, infrastructures, and applications. So this is a big idea. Related to AI, AI is the best and the worst of things. If we take AI on our big computers, we can use it to optimize them, by the way. Okay, like everybody can optimize any kind of system with AI, okay? But the main point is we can boost AI and we can help optimize big AI training and even inference using HPC big irons, and that's good. The problem is AI is way too big and is growing too fast. This is not sustainable. So AI has really to work together with us when they use HPC resources on being, I would say, more efficient, using maybe smaller data sets, using more efficient approaches to training and inferences, because training can take 3 months, but it's done. It's big, but it's done, it's updated. But inference can be billions of requests on the fly, so it can be extremely costly as well. And the technology and application setting is not the same. So we can help on all those aspects from our HPC centers. That's another big idea. And another perverse effect I would mention is that AI is changing the game, again for the better, but sometimes for the for the worse, because they now drive the evolution of processors. To, in particular, big ones for AI, GPUs, TPUs, or whatever. Okay, so they optimize a bit for AI. In my opinion, they should optimize much more, but that's another story. The problem is our HPC can help do some AI, but the AI processors are optimized for AI, and this tends to make HPC, I would say, more and more of a niche and not a priority for the processor manufacturers and vendors. And our HPC, this is very cool, is becoming typically less efficient just because the processors developed by AI and driving the market, and GPUs in particular, that might appear as good processors for saving energy are not helping HPC at all because they work in reduced precision. And that's really a perverse effect. AI, we can help it, okay, we can, but AI is so big, so huge, and it's moving so fast that it really pulls the processors on their side and makes HPC, which is extremely important, useful, and is here to stay for so many people, makes it more difficult. I will start here with those few ideas and we'll see.
Yeah, no, it's thank you very much, Philippe, and interest in this case, no, on this case that you just explained, how this is driven really is driving this new processors and how this has a positive effect, but also this negative effect. And I hope we can go a bit more details on the second round. Because you touch on many important parts, but actually you touch on one that I think we will get a few answers now in relation to how optimize AI and what are the now the strategies also to make AI more efficient. And for that, I would like to invite, we have two additional speakers, both coming from the AI research part, and I would like to invite first Jan-Willem van de Ment from the University of Amsterdam, and give you the floor that you also introduce a bit yourself more, and of course give us information about this European Lighthouse of AI for Sustainability, the ELIAS project. Thank you.
Yes, hi, Anna, thank you. And thank you for the invitation to speak. So as Anna said, I'm here representing ELIAS, the European Lighthouse for AI for Sustainability. This is a research network with 34 partners in 17 countries. It is affiliated with the ELIAS Society, which I'm also part of. And that's kind of course, a larger network with over 1,000 members throughout Europe. So the goal of ELIAS is to organize the AI community around challenges that can impact humanity. And here we consider these challenges at the level of the planet, the society, and the individual. Now, what I'm representing here today is kind of the aspect of ELIAS that focuses on kind of the planet or sustainability. And here, I think our goal is really to accelerate progress in research on challenges, and we view these challenges in terms of use cases. So we have a use case focusing on energy usage of climate control systems in buildings. We have one on developing AI methods that can forecast vegetation state in kind of like climate modeling. And there's a third use case which focuses on the developing a competition for AI methods for material science. Now, all of these, I think, use cases require solving hard technical problems. We need kind of AI-based methods that can help us kind of screen kind of a very large number of candidate designs and then kind of zoom in on the designs that are most promising. Often we need AI methods that can make predictions about systems that are very difficult to simulate, either because we don't understand how they work, and then we would like some form of hybrid kind of approach where it's partially data driven but partially informed by what we know about the system. Sometimes it's just because we can simulate these systems, but we can't simulate them at the scale that we would like. And there we need AI methods that can give us reasonably good but very fast approximations to extremely expensive computations. Now, finally, there's also, of course, an aspect that we've been talking about here, which is that AI computation itself consumes a substantial amount of energy. And Enzo will talk a bit about our efforts on energy efficient AI. Now, finally, I'd just like to point out that kind of Elias, as kind of something that's affiliated with Ellis, also does a certain number of community organizing efforts. So we have a researcher mobility program that facilitates kind of research visits between institutions. We have a PhD and postdoc program where candidates are jointly mentored by mentors at 2 different institutions. And we have a sciencepreneurship program where we try to stimulate young researchers with entrepreneurial ambitions to realize those ambitions. Okay, so I think we're quite over time, so I'll yield the remainder of my time and hand off to Enzo.
Thank you very much, Jan-Willem. And we have a second round now. I have a specific questions for you, but we will go to the second round. I muted myself to give the floor to Enzo Tartaglione. Really, you are also part, Enzo, of the European Lighthouse of AI for Sustainability, and you are part of Telecom Paris. So please, just a short introduction of yourself, and also I think you cover more the part of the efficiency on the AI side. So very, very much interested in knowing a bit more about your work.
Yes, thank you very much for the invitation here today. It's a big pleasure to be here. And yes, I'm indeed part of the Elias project, and I lead the one task which I think is very important in the project, which is reducing the energy requirement of computation, more specifically computation related to artificial intelligence. And I have to say one specific algorithm related to artificial intelligence, which is nowadays very popular and at the same time popularized, I have to say, which is deep neural networks. Now, until now, we have been talking about artificial intelligence energy consumption quite extensively in both sections, I have to say. But what I can bring here in discussion is a more in-depth analysis on how artificial intelligence and deep neural networks more specifically can really impact in the energy consumption. Because essentially, I'm not bound to any industry in my research. I do more base research around the topic. Now, if we want to really decompose the aspects that are impacting at the complexity of deep neural networks related to power consumption or resource consumptions in general, we can decompose it into essentially 3 different phases. The first one is, of course, data. Now, it is broadly known, and it was also recalled before, that these models require big data to be trained on. And very recently, this has been kind of solved, brute forced with the training these huge, big foundation models that now we can just download and deploy on our downstream tasks. And the fact of requiring big data also was a technical challenge, because the problem was that data kind of were already there at a different scale of what we have today, of course, but they were kind of there. But the problem was that they were not annotated, and annotation cost was very high at the human level. And there were been solutions to try to address this, and that's thanks to this that we can benefit of these models. Evidently, we can have other approaches that can avoid the need for having this big data, one of which is using proper priors. For instance, like we can think of physics-informed models, where we inject the knowledge of physics, and the required amount of data to train these models is much reduced, or to exploit previous knowledge, taking these models and properly adapting them for a downstream task where we don't have much data availability. Then, of course, it comes training. Training these models was being remarked before by Petri and Jean-Philippe is not necessarily the most important aspect to analyze when talking about complexity in terms of efficiency and of resources, because the same model is trained once and used n times in the future. Still, there are some models that require continuous update, where in the cases of continual and lifelong learning. So addressing these challenges is still extremely important. And of course, the use of these algorithms. So once the model is trained, you want to deploy and to use it in the most efficient way possible. And of course, every time that we use these models, they require both some hardware, which can be very expensive. And so you don't have it at home. You need to use servers that are in the cloud. And so on top of the cost of using the AI algorithm, you need to also take into consideration transmission costs. So not only latency, but also the energy for the information to travel from your physical place to the server and vice versa, which poses, of course, other kind of issues. And besides all of this, moving the computation to the edge. I agree with Petri when he says that we should consider the full stack, and that all of these algorithms have been over-popularized and there is a lot of excitement behind these ones. But still, I think we are really just trying to scale up with complexity, willing to do many more things with these models. And we are considering less the impact that they have energy-wise. And I think the challenges are quite open. And I have finished my time, so I'm happy to continue this discussion in the second round.
Very good, Enzo. Thank you very much. And just some comments, as you were the one bringing the part of the data, and it's very good to see that there is research ongoing in this need to use less data. But also we don't have people representing data here today, but there are many efforts as well in making let's say the data operation, so to speak, as you said, processes like annotation and others also greener. So I think we are really working in all the different directions, and I hope also now in the second round we touch on, as you said, more on the usage side, and where we have a bit less control, let's say, on the amount of that usage, and connects a lot with one of the strategies that actually Monique brought at the very beginning on the education side, and making the industry, society more conscious of that every time we use technology, in this particular generative AI, we are really impacting the environment. But let's go now. I will stop sharing my screen so we see our faces. We don't have much time, but still we have the opportunity to have a bit of discussion. I could say maybe focus on the different strategies on the usage and strategies on reducing the impact of these technologies. And I will start with Jean-Philippe, as we have somehow all focused a bit on this HPC. So what are you doing now? What are the strategies in your community to reduce this energy consumption and to make systems more efficient? You already talked about making it more AI efficient, but what are your current actions and strategies?
Alors, let me give a few hints. I was in the process of writing a few ideas in the chat. I will finish that later on. First, like I said, we have to take care of general purpose computing centers with dozens of different application workloads and profiles. So the best we can do is carefully select the components for compute, but also for interconnect communication between components, for parallelism, memory, sizing properly the memory, trying to optimize data movements at the technological level and infrastructure design level. The urbanization of the computing center itself between the subparts, storage, compute, and this is very important. Exascale coming, it's not only exaflops, it's exaflops, exabytes, etc. Maybe other ingredients. So our permanent effort at the computing center level is first about that. Then we try to work at the infrastructure monitoring level and global energy use efficiency. So we monitor things, we monitor sometimes processors, blades, racks, cooling systems. We put directly cooling system in place to be more efficient. We monitor, try to fine-tune a few things, again, to balance an average use by different kinds of applications, from big to very big to smaller ones on the big computers. We try to reuse it as much as possible. At CEA, we have different systems, but the biggest one we currently have, 150 petaflops, we reuse the megawatts of heat to heat the whole site, which is like a small city, 2,000 500 people, and we replace the central heating system by just the heat of the supercomputers. We try to work on the whole life cycle, and we try to work with the manufacturers as well, so that they properly recycle, they properly size the systems. Some vendors we work with, like Evidanato, they make efforts to relocalize production and manufacturing closer to us in Europe, which is good for sovereignty, but also limits the transportation, because in the environmental carbon footprint of a system, sometimes it's off of it for manufacturing, and in manufacturing, transportation of elements across different regions may be dominant. So we are very, very aware and sensitive about that. On the other side, we try to make our users more aware. We give them hints of the cost of their jobs, etc. We try to optimize the scheduling, which is a difficult problem because very, very, very generic, and it has to be heuristic. There is no big scheduling algorithm to make it properly. We also work with technology suppliers to develop, at the European level, there are efforts to develop better processors, high perf, but still low power, ARM-based or RISC-V based. I will put the reference of the project related to that in the chat. What else? EuroHPC, another concrete example, is launching this year. This is selected and in the process of being set up, a big software project with many computing centers, which are our EuroHPC site, to develop layers of software to manage energy more efficiently and schedule those thousands of jobs, daily jobs, more efficiently on the computing centers. So it's a big development starting. It will take 2, 3, 4 years maybe. It's meant to be deployed in all EuroHPC sites at the end, which will be, it's already 9, it might be 15, 20 at this time, trying to pull methods, efforts to optimize workloads and to better monitor energy and to have some feedback loop between users, maybe applications sometimes, middleware, hardware, etc., etc. But this is a very difficult problem, and we are extremely pragmatic and use a lot of, I would say, feedback from the experiment or from the operations. Well, there are a few things I can mention, which hopefully have some concrete flavor.
It's excellent, and I mean, you are a community that you've been aware for a long time that you need a lot of energy, a lot of cooling, and I'm happy to see that many of the measures that you are putting in place is by designing, designing what components you use, how you connect the components. Also happy to hear about this project that will even look at the software and how also you use this concept of almost circular economy, to make sure that you as a data center benefit or make the citizens close to you benefit from the whole life cycle of energy. So I see strategies. We don't know whether it will be enough, but let's continue with the others.
We do our best. It's not perfect. It cannot be, but we do our best.
But I like that it's already by design. I'm very conscious of everything that you can do to optimize the system's energy efficient. Let's touch on other aspects. I'm going to touch now both Petri and Enzo. You both already brought up strategies from the AI perspective, from the data to the models to the usage to the bringing to the edge. But can you tell me, and I will address first Petri, where do you see, in which direction you see that we can really get more benefits in this energy efficiency? Is in the usage, and if so, what can we do? And what do you think that we need to put more emphasis in the future, for instance, research agenda or deployment agenda? And the question is for both Petri and Enzo. So, but Petri, I will address you first.
Okay, just 2 quick comments. From the machine learning point of view, I strongly believe that we are going to see a lot more data and energy efficient algorithms. We have been actually working on them for decades already. The current paradigm of this large-scale deep neural networks will not stand forever. That's clear. So let's continue working on that. And the second point is that, like, there was a question in the chat, like if we use AI for more resource efficient solutions for the world, is it guaranteed that they actually save energy instead of using it more? Let's keep in mind with all this hype that the whole world is not about chatbots. And large language models. If we talk about optimization of traffic or industrial processes, there are much more lightweight solutions that can be used. So it's not always that you ask ChatGPT like how to prevent global warming and what is the cure for cancer. This just won't work. So let's be more realistic also.
Yeah, that's very good. Very good that you first, very happy to hear that you see the future in this data and energy efficient algorithms, and that's the path that you see. Also very good comment, although it's true that the ChatGPT kind of applications has democratized, access, and now everybody's using it for absolutely everything. I think there is very little awareness in general public of the effect that has really in the environment. But very good point that actually different type of models and different type of behavior will come in the industry. That is where we will see a lot of benefits in the usage of generative AI. Fantastic. And so what is your viewpoint? What do you think we will find more efficient future in all these different paths that you touched before?
Yeah, to be honest, I totally agree with Petri. I think the research on efficiency has been brought up since decades. Actually, most of the research in AI is heavily inspired right now from the research done in the 80s, in the 90s, because we don't have to forget about that. Typically now the trend is to build larger and larger models, but finding a way at some point to collapse them, to really understand better how they work such that we can shrink them down, to make them more efficient, to go to something simpler, I think is gonna be the way to go on. Okay, so this has already 2 points. Good to see. Thank you very much. And so now, Jan-Willem, I'm going to address you. You have been actually talking about more the usage of AI for these great applications and these new AI methods that are being created. I want to ask you also, can you tell us a bit more of these new methods, their performance? You see really in the project that this is going in the good direction. And I would like to ask you whether in the design of these new AI methods, also the sustainability aspect of those methods is being taken into consideration to balance a bit the effect of the application from the effect of really either training or using any kind of method. Thank you for your input.
Yes, so I think there's clearly this trade-off, right? Like AI methods use a lot of energy, but can also help us develop new technologies. And I think that as an AI community, if we're going to work on challenges that can impact sustainability, we have to think about innovation. We work at kind of a relatively early technology readiness level. We need to generate ideas, but we need to be working on ideas that have a chance to scale up. So if we're going to work on things that are just going to have a marginal impact in terms of our carbon footprint, there's just no chance, right? And so I think at this time, right, it's a little bit unclear where the opportunities are, but I think as a community, we should start turning our attention to these opportunities. Some of the opportunities I see are AI methods for materials design, for example, to identify suitable materials for carbon capture. All of these, of course, have a low chance of probability, but I think we have to gradually organize ourselves around problems where, as kind of techniques become more proven, we can scale up. I think another good example is kind of, AI for kind of modeling fusion reactors, right? Like these are kind of things that, if they're successful, can actually have an impact in terms of CO2 reduction of several percent. And I think, anything that doesn't have that kind of impact, you shouldn't think about. I think regulation of building energy usage is a pretty good example as well. So that's, I guess, kind of what I'm here to say today. Yeah. Let's work on those problems. In terms of kind of the AI required there, yeah, I would like to echo what Petri says, right? We're not going to ask ChatGPT, can you please solve our kind of climate change challenges for us, right? That's like, I think kind of AI is scaling remarkably well, miraculously well. But if you need to solve a specific problem, I think it's going to be true for some time that there's a better path to victory than first training a large language model and then asking the large language model to solve the problem for you. So I think nobody in the AI community thinks this. I think maybe not even kind of the big industry players think this. What I do think is that there's opportunities to train models for specific applications like material science and chemistry. And so there, I think you can actually get away with smaller models. You can get away with smaller data sets. And the alternative, right, like, I don't know, the density functional theory calculations that you would use there also consume a ton of energy. So there's also there kind of an opportunity for AI methods to actually be faster relative to kind of the numerical computation baselines that are being used today.
That's very good. I like very much these last comments about the smaller models. And actually, I can observe already that in industries, all talks about these smaller models that can be also taken to the edge. But the point that I like very much of your final intervention is this: let's innovate, but let's innovate in things that can scale. And that's the important part. And what I see you quite positive and optimistic that also thanks to your Elias project, you will learn a lot about this possibility to innovate and scale. Thank you. We have two final interventions, and I know we are already a bit quite delayed, but I want to hear before we close now from Chris and from Armando, from both of you. You are more on the usage side, and you have heard all the aspects of the impact on the usage of these technologies, but can you tell me something about your investments in the sectors where you are? What are the strategies now to invest in these technologies for sustainability and in particular environmental sustainability? If you can say a few words to close, and that give us also an idea of what the different sectors are looking at towards the future. Chris, do you want to come first?
I can come first. Well, talking about investments, that's quite a heavy question for sure. What we see across all the initiatives, it's a more holistic approach to optimization, and that includes environmental aspects. It includes energy efficiency. It includes material efficiency. Coming to that, the bridge to circular in manufacturing also has a huge impact on resources you require to create prosperity and to create an economy that works. So the effect of the optimization goes very far. It's a big topic, but it's not only about how much power a device or a machine consumes.
Yeah,
so
it's
there's
looking
a huge,
at the whole. Yeah.
So and that's clear. And I like very much the references to, I heard lightweight solutions. It's not going to be ChatGPT that's going to solve all the issues. And making it short, there are projects that look, for instance, into the use of knowledge graphs. And I've seen actually quite recently a presentation comparing, the large language models with, in terms of energy consumption, resource consumption, comparing it to knowledge graphs. And there you see, of course, if you put more knowledge that into a model without trying to get it out of a large computing device, I think it's making the best of both worlds that we will do in the future. And I'm very happy to hear the developments that go in that direction, that we can get away with small models as well.
Yeah, that's very good to hear that in manufacturing you are looking at this combination of knowledge graphs and LLMs, and in general, very good to see that you look to the overall life cycle and looking at optimization, circular economy, and I know how much AI data and robotics actually are connected to it. And now, Armando, tell us from your side how you see in the sector the strategies to keep investing or.
Yes,
investing is not only money, but using these technologies.
Yes, so I think one of the highest interest and revenue for this kind of application should be in the traffic management for railway and railway networks. Because one of the lacking things of the railway network is capacity. That's the reason, for example, that in Germany all trains are delayed. There's too many trains. But with more efficient traffic management, it is possible to reduce that and insert even more traffic in the networks without needing to invest in the hard infrastructure like building more rails or whatever. So I think that's one of the applications. There's a need of research projects on that that investigate as well the trustworthiness of these AI technologies. Another issue I also commented is between the different countries when it comes to cross-border traffic, how to solve these different and certification issues for the safe operation of the railway systems. And finally, I think one of the is also in maintenance process and inspection. How to deal with all this data that is arising from all infrastructure, bridges, tunnels, platforms, etc. So I think on that area, and as well autonomous driving assistance of the railway, and finally logistics operations, how to get trains full and freight and with passengers. So I think the need of projects in that research project is huge, and I think this the advantage of doing it with artificial intelligence could help improving the use of railways, and therefore consumption in or production of CO2, decreasing it.
Okay, this is excellent, Armando. So we are closing. Thank you very much. We see that all the different sectors keep investing and using, and see a lot of possibilities to keep using AI, data, and robotics more and more for sustainability and energy efficiency. And I'm very happy that also there is a path towards making these technologies by design more efficient as well, looking at the whole life cycle, the whole stack. So I think we are positive, but of course there is a lot of work to do. And thank you for all the input in the final session of today. We will debrief of the outcomes, and I hope that's useful to the upcoming strategic agendas and paths to take together. Thank you very much to all the speakers. And now, Philippe, I give you the floor back a bit late. My apologies for that.
Not a problem whatsoever. It was a brilliant panel, and thank you very much for the contributions that came from all of the speakers, and for the moderation as well, Anna. Thank you very much. So we move swiftly onwards at this point, and we're going to take a look at a number of exhibitors in our kind of second round. So I will be welcoming onto the stage in a moment Iñaki Sainz from Corob.
Yes. Hello. Here I am.
Thank you.
Yeah. So I just want to bring your attention to the Corob project we are working on. It's a project for making research in cooperative robotics. Of course, there will be AI, there will be inspection, there will be data. So it is quite an interesting project. We are working on getting very interesting results. So I wanted to bring your attention, all of you, to visit our booth. And also, we do now have an opportunity with an open call that is open until the 8th of July, and you can receive up to 150,000 euros for collaborating in this project. So you're all invited to take in this opportunity.
Great. Thank you very much. Next on this is Emeralds, Nicholas Ferguson.
Hello there. Good afternoon, and thank you for introducing me. So my name is Nick Ferguson. I'm a Senior Project Manager and Shareholder of Trust IT, and we're one of the partners in the Emeralds project. So many of you may have been traveling to work today by public transport or even by car, and you may have been stuck in a traffic jam or had your journey blocked at some point. And this is mainly because more and more people are living in cities across Europe and using the roads and using public transport. And as cities grow, so does congestion and problems as well for citizens and for just moving around. At the same time, there's a huge amount of data available to cities and city administrations to actually improve the way that urban mobility is managed. And this is largely untapped across Europe. And this is where the Emeralds project comes in. So Emeralds is a 36-month research and innovation project. We are at month 18, so we're halfway through our project. We look to provide and develop an urban data-oriented mobility analytics as a service. So we're creating a tool set for city administrators and managers who can improve the way that urban mobility is managed in European cities. We're using advanced technologies such as AI, big data, edge, fog, and cloud computing to build a tool set. And with so much data, one of the key aspects of the tool set is to understand which data is important and which data is relevant to the various challenges that a city experiences. We have 3 exciting use cases across Europe. Firstly, in The Hague, which looks at risk management for events, so such things like political demonstrations, which take place often in The Hague. And here it looks at predicting and forecasting the various factors that can lead to crowding and congestion of people within a city. You may have seen this during the football championships in Europe, in Germany as well. Also, in Rotterdam, there's a multimodal integrated traffic management system being introduced to improve the way that traffic management strategies are employed. When do you close a road? What's the impact on local businesses, etc.? And then the final use case is in Riga, in Latvia, which again looks at improving traffic flow by using data analytics and improving the situation. So the next time you're stuck in a traffic jam, think of Emeralds and have a look to see at the progress that's being made in this project. Thank you very much.
Great. Thank you very much. Next is Adra-e, Hussein Mansour.
Yeah, hello everyone. So Exanodia is a project which deals with inspection, industrial inspection, and what we call non-destructive testing, powered by artificial intelligence. So the issue we are trying to solve is the following. You know, in medicine you have medical imagery. You do X-ray, you do ultrasound ecography in order to detect pathology in the human body. In the industry, we use the same techniques in order to detect metallurgical defects in industrial equipment, like nuclear power plants, oil and gas facilities, in naval shipyards, and so on. So this sector is growing very rapidly and at a fast pace globally, but manufacturers and operators face significant difficulties in controlling their assets, their production, because of a global shortage of skilled human resources. So these pain points induce manufacturing delays, significant non-quality costs in a sector where the job is to detect non-quality. So it's a bit weird, and also risks to facility safety. So our promise or our value proposition is the following. We propose inspection and non-destructive testing solutions powered by artificial intelligence to automate, speed up, and make control processes more reliable in order to ensure safer industrial equipment at the lowest cost. So that's what we do at Exanodia. We invite you to visit our booth and don't hesitate to ask us for more information. Thank you.
Thank you very much. Next, we have Intelliman, Gianluca Pali.
Yeah. Can you hear me?
Yes.
Okay, great. So thank you and good morning, everyone. I'm Gianluca Palli, the coordinator of the Intelliman project. So I don't see the slides yet. In any case, Intelliman focuses on the development of robots that can efficiently learn to perform manipulation tasks in a highly targeted, high performance and safe manner. So the project aims at developing a novel AI-powered manipulation system with persistent learning capabilities, able to learn individual manipulation skills from human demonstration, learn abstract description of manipulation tasks suitable for high-level planning, discover functionalities of objects through interaction, and guarantee performance and safety via automated and adaptive full detection and enhancing user acceptability. In our consortium, we have 13 partners among universities, research centers, and industries, and we have 4 use cases. One is devoted to prosthetics, one to robotic services for home applications. One is related to industrial manufacturing, and the last is related to fluid manipulation for logistics in supermarkets. I invite you to visit our booth, in which you can see the last results of our demonstrators, in which you can see here in the slides, you can see some pictures from them. So we are almost middle of the project, and we already achieved relevant results in this direction. And so in the booth, you can see videos showing the modules that we developed that are tested on the different platforms and on the different applications in order to validate their capabilities and demonstrate the applicability of the same methodologies through different platforms and different domains. Thank you very much.
Thank you. Next, we have reproduce.
Hello, can you hear me? Okay, thanks for the introduction. I would like to, sorry, I don't see the presentation.
1 second. It's up.
Okay, thank you. Thank you. So I would like to present to you this European project. The main idea is that currently in Europe, we have a huge problem with raw material, having a total dependency of China for buying these materials. So the main goal of this European project is to build a whole recycle chain in order to recover raw material from electronic products. Okay, so in this case, the target are in this specific project, the target are the permanent magnets based on neodymium and the batteries. So our specific work in this project is focused on the development of a dismantling robotic machine able to disassemble the product, in this case overboards and hard disks, in a complete automated way. The robot has a camera, and using computer vision and artificial intelligence, we are able to detect and classify all the elements of the product. With these products, we have more than 35 different elements, for example. And so we can guide the robot in the different manipulation tasks, as drilling and screwdriving, sucking, grasping, etc. So we think that in the near future, this kind of automation will be critical if in Europe we want to reuse rare earth elements for giving them a second life. So I invite all of you to see our showroom, and thanks for your attention.
Thank you very much, Diego. And finally, tuples or tuples, Michele Lombardi.
Hello, everybody. I'm Michele Lombardi from University of Bologna, speaking about the Tuples project, which is about trustworthy planning and scheduling with learning and explanations. So our starting observation is that combining data-driven AI method with traditional planning and scheduling techniques has shown us a lot of promise recently as a research direction. It solves a lot of issues, especially related to how to handle uncertainty, but on the other hand, it also introduces a lot of problems related to the trustworthiness of the resulting system. This is due to the black box nature of data-driven AI. So in the project, we aim at improving these hybrid methods for addressing planning and scheduling general sequential decision-making problems by focusing on three main technical challenges. So on one hand, we want to make these methods more scalable, especially at training time, which is the current blocking point. We want to improve their robustness and safety, in particular focusing on providing guarantees, on having the abilities of providing safety guarantees. And we want to make them more explainable, which is a challenge because these methods feature both the decision support component and a machine learning component. So we are dealing with 5 use cases from aircraft manufacturing, flight rerouting, waste collection, unit commitment in energy management systems, and soccer team management as the last one. So we're going to deliver some public benchmarks and simulators. One is ready, the others are to come, and we're going to host a competition with a money prize on tackling a planning problem by means of hybrid methods. You can find us at our virtual booth or on the project website, which is https://tapples.ai. Thanks.
Excellent. Thank you very much to everyone who pitched just a moment ago. Really great to see so many interesting projects and innovations happening within all of those projects.